Guys and girls, it's know it time! Know it time!
Alright, I'm going to start a new chapter with you today, and this is called polynomial functions. It's a polynomial function. Hi. Oh, please, come on. Enough joking with Taryn. Let's get serious. So here, 5 minutes, come on, it's a minute more like it. Here is what we're going to start with. I finished probabilities. Now we're going to do polynomial functions. A polynomial function, I'm going to repeat a few key things. Write this down, star. A polynomial function contains, again, I'm going to steal this definition straight from the textbook. I'll explain to you what it is in real life in a second. Only the operations multiplication and addition slash subtraction. Now I'm going to add in this word subtraction because a lot of people can get confused and they say, what the heck is this? Okay. So, number one, a polynomial function contains only operations of multiplication and addition slash subtraction. That's the first key thing. Number two, must have real number coefficients. Real number coefficients. So what it must have? Coefficients. And finally, one last one. The last star. Exponents must be whole numbers. Your exponents must be whole numbers. Okay. So I'm going to give you an example, and you're going to see why this is called polynomial function. Guys, example. 3x squared plus 2x minus 1. I'm going to look at all my criteria to see if it's satisfied. If I look at my criteria, number one, it has multiplication, addition slash subtraction, yes. So criteria number one is check. The coefficients must have, how come it's not showing up? Real number coefficient. So look at my coefficients. If my coefficients have real numbers, criteria 2 is check. Okay. Next thing, your exponents must be whole numbers. Look at my exponents. Check. So therefore, this is a polynomial. This is a polynomial. Voila, that's what it means. Try this one. What if I give you 3x to the power of 1/2 plus 4? Okay, a bit more challenging. Leinard, yes or no? Why? Which one does it fail? The exponents. So guys, gals, this is the sort of thing I'll be teaching you. This is called polynomials. Now, we're going to draw a little chart. I'm going to go through the 3 basic types of polynomials in grade 12. 3 main types. Sorry? No, it doesn't have to have subtraction. I'm saying slash addition or subtraction. So here are the three main types you have to work with. In grade 12, there's three main types they teach you. Okay, and I keep it simple. Again, I'm going to give you more definition as we go along. So for now, we're going to draw a chart. Take a minute, guys, gals. I want you to produce my chart. Exactly what I created for you. Here, I'm going to write down equation. What the equation going to be? Here, I'm going to write down the degree. Okay. Here, I'm going to draw a rough graph. I'm going to ask you a few more things. Here, I'm going to ask you for end behavior. Here's a new word, behavior. Okay. I'll explain to you what end behavior is in a second. Voila. Here, actually I'm going to do one more chart. This will be my domain range. So I have a chart. I'm going to start off with a simple one that everyone learns before. This is Y. In grade 10, wow, you're correct. In grade 10, your teacher taught you an equation. Y equals to 3x, come on, my pen's not working, plus 2. Without my help, guys and gals, I want you to draw a rough sketch. Go. Just imagine, I'm going to pause. Guys, I walked around and somebody say, hey, Mr. This is called equation of a line. Back in grade 10, your teacher taught you mx plus b. I walked around and most of you got this correct. You say, we're going to start at 2. And your slope is 3, so you go up to 3. Look something like that. Voila, that's correct. Now, there's a new word I'm hucking at you. I'm not sure if you know this word yet, but degree. That is, you're right. Degree means highest exponent. It's a fancy word of saying highest exponent. Amit, what's the degree going to be? Not 3. Sorry? 1. Because your exponent here is a hidden 1.
Your highest exponent?
Yep. Because there's an exponent for x, highest exponent for x, which is 1. There's a hidden 1 right here. So what's your highest exponent? 1. That's your degree. Now, here's another one. This is called end behavior. This means explain the graph Oh, you better know all this term. They will ask you all this term. Give me 1 second. From left to right. That's what it means. Explain the graph from left to right. If I look at the graph left, it starts right here. You got to know how to label your quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So it says explain the graph from left to right. So we're going to say this. The line goes from quadrant blank to quadrant blank. Line goes from quadrant No, you go from left to right. So as long as you look here. So yes, basically. From quadrant 3. Because look, I'm starting here. From left to right to quadrant 1. Voila. Yep, it's always going to start with quadrant 2 or 3. And then you explain which way it's going. This is called end behavior. Easy. Guys, gals, domain and range. You should be able to do this from grade 10. Back in grade 10 days. In there, what's your domain going to be? Domain is not 2. Domain means what are all the possible x values. If my line keeps going this way, is it possible to have every x value in the world? Yes. So this is called all reals. Or the book like to use reals. Okay, so we're going to write down all reals. Which means you can have any number you like. Range. Gerdemon, what's the range going to be? Look at it. Range means the y-axis. You're going to go, can you have any y value you like? Nope. Nope. All real numbers too. See, look at my graph. It keeps going up, positive. And look at my graph keeps going down, negative, infinity. Yep. Domain is what are all the x values you can have. Okay? And look at my line. Would you agree my line will touch every x value if I keep on extending? So that means all reals. Okay, now if I look at my range, it means what are all the possible y values. And my line keeps on hitting every y value from negative infinity to positive infinity if I keep on extending this. This is called degree 1. Okay? I'll give you more practice in a second. Next thing. Y equals to, this is from grade 11. Show me who remembers this stuff. X plus 3 squared minus 2. I want you to tell me what degree it is, and let's see who remembers from grade 11 what the graph looks like. I'm going to pause it. Guys, here we go. Now, the name of this I heard starts with letter P, and this is called parabola. Or some of you call it parabola. It sounds like a virus. Have you seen that movie, Breakout? Or whatever it is? Yeah, I think it's it's about the Ebola virus. So, next thing, degree. Tia, what's the degree going to be? 2. Degree means the highest exponent. Look at this. The highest exponent is 2, so we're down 2. See, very nice. This doesn't require logic. It requires me to see it and look at it. Now, here's what we're going to do. I'm not sure if you remember this or if you did this in grade 11, but I'm pretty sure you did. See, this is called a parabola. A parabola has this shape, and you're going to need to know the vertex. The vertex of this parabola, I'm not going to teach you how to do this yet, but I'm going to tell you right now, is going to be -3, -2. You switch a 1 in brackets. Yep. Some of you are starting to recall this. Good. So put a dot right here. Sorry? That's later. So I put a dot right there. My parabola is going up. See, it's going up. This is called a parabola. Very nice. So look at this. If my degree is 1, it will always be a line. If my degree is 2, it will always be a parabola. No exceptions to this rule whatsoever. Now, I want you to write down my end behavior. Go. Of course, sorry, the graph should have gone all the way to 1 and all this stuff. You're going to say line goes from Taryn, well, what quadrant? Sorry? Sorry, I didn't hear you. No, not 3. 1 is right, but not 3. Nope. Goes from quadrant. Where?
Oh, okay.
How?
That one, 2 to 1.
2 to 1. Hi. Quadrant 2 to 1. That's what end behavior means. Where does it start? Where does it end?
Wait, how is it 2?
Sorry? See? I start here.
Yeah, it's very continuous.
Yep. That's where, see, this is where it gets a bit tricky. Next thing. My domain and my range. Here's a bit tricky for you. Domain. I'm going to start with domain for you. Domain is your x value. Look at the graph. Domain is best found by analyzing the graph. My graph, you ask yourself, can it be any x value you like? Yes or no? Close. That's you're thinking range. X value is this way. Notice my graph hits every x value that you have. So therefore my domain is all reals. You don't get that? Okay, so let me explain to you one more time. See, look at my graph. Okay, I'm going to draw this a bit bigger.
It only hits 2.
Domain means x values. That's what domain refers to. Okay? X value means this way.
Yeah, okay, and it hits it twice.
Okay, no. Give me 1 second. It means what value does this line... Oh, come on, where's my hand? It's my computer slow. What value does this line cover for the x? Notice I can have an x value here. I can have x value here. X value here. Everything has an x value. See, there's all x values along this line. This line touches every x value there is. Nope, everywhere. Now range, so that's why my domain is, now look at my y. My y touches everything up here, but there's the spot it doesn't touch. Does the graph touch any points below here? No. So my y range is y is greater or equal to -2. Because here's the reason why. This is the lowest point you can have, -2. My graph doesn't touch anything below -2. That's why it's -2. Yep. Guys, we're not even done. This is just the basics. And like I said, this stuff is not about logic anymore. Some of you wish you can go back to logic now. So range. Y is greater than or equal to 2. Or sorry, -2. One more keyword I'm going to teach you. This is called turning point. And turning point, I'm not going to teach you what it is. I want to see if you can figure out from the name of it. How many turning points are there? 1 is correct. Turning point means how many times does the graph change direction, if you want to think about it. See? Look, there's a turning point right here because it turns right at this one. So a turning point is 1. This is called a parabola. Y equals to something something. Is either 1 or up here, how many turning points do you have? 0. We're not done yet. In a second. So I'm going to give you, what if I give you this negative x plus 3 squared minus 2. So look at this now. I'm using negative. I want you to complete the chart, and I'll give you a hint. My vertex is still the exact same thing, but there's that negative changes one thing. Let's see who can figure this out. I'm going to pause it. Everything is the same. Idris, what's the degree going to be? Degree is 2, correct. So my degree is 2. My vertex, I'm going to tell you right off the bat. -3, -2. Hi. There is, P is right here. Yep, Q is outside. Then I have draw a grid. Again, let's erase these lines. These lines are annoying me. Did they look ugly? Now we go. So this, -3, -2, it's going to go down this time. Because of the negative. Negative changes from what you call from beginning. Because it was a positive. My end behavior also changes. Look at my end behavior now. Goes from 3 to 4. Is correct. So I'm hucking a lot of vocabs there at you. Goes from quad 3 to quad 4. Kyla, how many turning points do you have? You have 1 turning point. So from one graph, I can ask you a lot of different questions. Okay? Who haven't asked yet? Karamjeet. What's your domain, Karamjeet? Domain is all reals is correct. Because my graph touches every x value. Gurjot, this is a tough one. What is your range going to be? You're correct. Y is what? It's, yep. Because look at the graph is going down. There's nothing going upward. Less than or equal to, keep going. -2. This is the sort of thing I'll be asking you on your exam. I'll give you a quiz, a graph, and you can go through and tell me all this stuff. Height. Height. Just exactly like this. You fill in the chart and based on all vocabs. Yep.
Does the quad always start from 2 and 3?
2 and 3 always. Because you can describe it from left to right. Okay? Guys, gals, up, question. It just flips it, yep. You got to know what the original looks like and then flip it. Okay? Hi. Good question. I'm going to show you in a second. Okay? That's for later. That's for the odd ones. For now, I'm going to start with next one, guys. This is something brand new now. This is where Math 12 kicks in. What if I give you this? Y equals to x cubed plus 3x squared minus 2x plus 4. I'm going to start with simple stuff. Let's start with my degree. What is it? Degree? 3. There's a name for this graph. Number 2 was a parabola. Number 1 was a line. This circle.
This is the weird,
Caterpillar. This is called cubic. Because it has 3. Cubic. Guess what number 4 is called? We are going to learn number 4 also. Quartic. Okay. So right now we're working with cubic. I do not expect you to know how to draw this properly, but I expect you to know the shape. So I'm going to show you the shape of it. Quadratic formula. Do you know it? Oh yeah. That's for later. Yep. Yep. So here's how it works. You start here. You go up. You go down. And you go up. Mario!
Why did you come?
Whoa. He's always welcome. Come on. So guys, gals, this is called degree 3. Okay, so look at this. A cubic equation starts here, goes up, down, and up. I'm gonna. Doesn't matter as long as it looks like this. Because it's going to look like this no matter what. Here's my next thing. I'm going to ask you turning point. Okay. Turning point. I'm going to ask you domain. I'm going to ask you range. I'm going to ask you what else? End behavior. There's no vertex. You don't know. You don't need to know the proper how to graph this properly. I expect you know the shape because there's a way to go. That's not yet. In the future, I will show you how to do it properly. But for now, you expect to know the shape of it. If I give you this shape, you should say, Mr. That's a cubic function right off the bat. Yep. I will give you the shape, and then you have your TI-83. I'm going to show you how to use it and learn how to graph it. N behavior. Turning point. Guys, I'm going to pause it. Turning points. You need me in my Lavraj. How many turning points do you have? Yep. Sorry? 2. Nash. 2. Done. Hammer, domain. All reals, correct. Navdeep, range. Sorry? Kanisha, range. No one has range? Range? All reals is correct. Reason why, look. My graph goes through every y value there is, and it goes through every x value there is. N behavior, her jazz. What's your N behavior? Quad 4 to quad 1. Nope. I only need from start to end to quad 1. Voila. Guys, gals. Oh, sorry. Her jazz. Bad her jazz. Bad. Bad her jazz. Bad. Quad 3 to quad 1.
Isn't that 1 to 1 though? Top 3?
Yeah, so this is 1, 2, 3. You're always looking from left to right. Yep. So that's 3. Hey. Next thing. Without my help, I want you to do this now. Y equals to negative 4x cubed plus 2x minus 1. Let's say I want you to draw a rough sketch for me. Go. Start with a rough sketch. Again, some of you asked me, so what about the x, y intercepts and all this stuff? Guys, gals, I don't care about that for now. I'm more interested in, do you know what the shape's going to look like, general shape?
It's just going to be an upside down.
Draw it in.
Look the same always. Cubics always go the same.
I have no idea. Draw it in. Tell me all the stuff I'm looking for. N behavior, turning points. I'm looking for a domain. I'm looking for a range. Question is, what's your N behavior? I can figure out if you got it right or wrong by looking at your N behavior. Now read, what's your N behavior? Three to 4? 2 to 4. Okay, so let's look at this. Let's draw my graph. The first thing, I notice you should be focusing on this. There's a negative sign right there. The negative changes everything. Okay, so it changes. Look how I'm going to change my graph now. Doot, doot, doot. See? Sorry? That's why you got to know the shape. Everything is based on the shape. Okay? Height. I'm going to show you a trick to memorizing the shapes in a second. It's one of the coolest tricks in the world, and I patent this trick. I copyrighted. Oh, I'm going to show you. Relax, breathe. Degree. I always start with degree. And my degree, to save you time, I'm going to say is going to be 3. Everything stays the same. There's no difference. Now, some of you ask me, how do you know what the shape is and all that stuff? I'm going to show you a magic trick. We're going to write this down. Your success or failure in polynomial lies in this one sentence right here. I kid you not. I copyright this. This is copyrighted material. No is a positive winner. Copyrighted. One sentence will either give you an A or a B on the exam. If you remember this, it will give you an A. Some of you ask me, so how do you remember this? Let's look at this one. I see the word positive here. I see the word no. No starts with the letter N. So, a cubic equation, guess what letter that is? Look at that. Oh my god, it looks like the letter N. Okay. Now, why does this W winner come in? Because winner starts with a W. And guess what the quartic shape looks like? I'm going to show you in a second. So this here is your cubic shape. For a positive, because no is a positive. I also highlighted the W. Guess what that shape is for? This is cubic. This has to be quartic. And on grade 12, you have to know up to quartic. In universities, you learn up to 7 shapes. Grade 12 is only 4. Okay. University, they work up to x to the power of 7. Is it that much harder? No, not really. So guys, gals, this is how we start N. When you have positive, it's going to look like an N and a W. Try this on your own. Y equals to, again, I'm going to make it up. What I want you to focus on is a concept, not the exact shape for now. Minus 1 degree. TP is turning point. Graph without any help for me. And degree, turning point, graph. What if I have domain, range? I'm going to pause it. Yes. I see a 4. I know this is my quartic. 1, 2, 3. Hey, it does look like a W. That's why no is a positive winner. Oh, one sentence. Either make you or break you. No is a positive winner. That's what you're going to predict later. But that's not. That's why for you guys to figure out. Turning point. 3. My graph is done. Domain, all reals. My range, all reals. Well, technically this should go down further, but domain, for now, leave it blank because it's a bit tricky. Goodbye, guys and gals. Leave domain. That is the basics of everything you have to know. Tomorrow, I need you to have a TI-83. We're going to work with TI-83. Your work. Page. 383. Doesn't this chapter look a lot easier after you've done probabilities? Yeah. Oh my God, Mr. No, what the heck is this? This is a joke compared to what we've gone through. Page numero 1. Numero 2. That's all you can do for now. That's it. And notice, guys, my polynomial function is smooth. It has turning points. That's it for now. And